Why does anything exist? Why is there something rather than nothing? Wouldn't nothing have been so much easier? This question has awed and mystified people throughout time. Quote, "The first question which we have a right to ask will be, why is there something rather than nothing?" Gottfried Wilhelm Leibniz in The Principles of Nature and Grace, based on Reason, 1714. Quote, "Not how the world is the mystical, but that it is." Ludwig Wittgenstein in Treatise on Logic and Philosophy, 1921. Quote, "No question is more sublime than why there is a universe, why there is something rather than nothing." Derek Parfit in Why Anything? Why This? 2008. Martin Heidegger called this question the fundamental question of metaphysics. But it might as well be the fundamental question for any being. Our existence poses a mystery that demands an answer. Where does it all come from? Why is there anything at all? Every society in every time has wrestled with this dilemma. It's our most enduring question. For we all seek to know why we are here. Lacking an answer, we are like a ship adrift. Our ignorance on this question makes us like an amnesiac who awakens in a dark and strange place, knowing neither where we are, nor how we got here. Some say without an answer to this question, we can't know anything. Quote, "It is possible to think that one cannot answer any question if one cannot answer the question of why there is something rather than nothing. How can we know why something is or should be a certain way if we don't know why there is anything at all? Surely this is the first philosophical question that has to be answered." End quote. Robert Nozick in Philosophical Explanations, 1981. With an answer to this question we could orientate ourselves. We would know our place in reality, and understand the reason behind it all. An answer to this question would tell us not only why we exist, but also what else exists, both within the universe we see and beyond. But can this question even be answered? Some have suggested the answer is unknowable. Quote, "Who knows truly? Who here will declare whence it arose, whence this creation? The gods are subsequent to the creation of this. Who, then, knows whence it has come into being? Whence this creation has come into being, whether it was made or not, he in the highest heaven is its surveyor. Surely he knows, or perhaps he knows not." The Hymn of Creation in Rig Veda, circa 1500 BC. For most of history, the question remained beyond the possibility of being answered. But we live in a most exciting point in time, one where this question has fallen to the progress of human knowledge. In the past decades, results from physics, cosmology, mathematics, and computer science have coordinated at last to solve this timeless question. We can now say, with some confidence, why we exist. The answer we have is more than an idle philosophical speculation, it can be observationally tested and thereby be confirmed or falsified. So far, observations are in agreement with this answer. Let us retrace humanity's steps in finding this answer, and see what this answer reveals about the nature of reality and our place in it. Two paths to existence. One reason we find why does anything exist so difficult is that there are only two possible answers, both are repugnant to our intuition as each contradicts our common sense understanding of the world. Given something exists, either 1. Something emerged from nothing, or 2. There are self-existent things. The idea that something came out of nothing is contrary to reason. How can nothingness do, never mind create, anything? The idea that there exist self-existent things is contrary to experience. Everything we know appears to have a preceding cause. How could anything create itself, or exist without some creative act? And yet, that one of these answers must be right, seems inescapable. There's no other way to reach something exists without either starting with something at the beginning, or starting with nothing and having something emerge from nothing. If we seek an answer to this question, we have to be willing to accept an idea contrary to our common sense understanding of the world. But which of these paths leads to the correct answer? Something from nothing. The first of the two answers is that something emerged from nothing. But how is this possible? Does it even make sense logically? For at least 2,500 years, humans have debated whether anything can come from nothing. The Greek philosopher Parmenides made the earliest recorded argument that nothing comes from nothing. Quote, "I will not permit thee to say or to think that, being, came from not being, for it is impossible to think or to say that not being is. What would then have stirred it into activity that, being, should arise from not being later rather than earlier? So it is necessary that being either is absolutely or is not." Parmenides in The Way of the Truth, circa 475 BC. To decide whether existence emerging from nothingness is even logically possible, we need a precise definition of nothing. For instance, by nothing do we mean no things, or do we mean absolute nothingness, no laws, structures, properties or principles? Defining nothing. Quote, "It might have been true that nothing ever existed, no living beings, no stars, no atoms, not even space or time. When we think about this possibility, it can seem astonishing that anything exists." End quote. Derek Parfit in Why Anything? Why This? 2008. What is nothing? It seems like a straightforward question. Just keep removing things until there is nothing left. Start with the universe as it is. Wipe away all the matter and energy. Take away all the quantum fields of the vacuum, and any virtual particles popping in and out of existence. And voila, nothingness. Nothingness is reality after we delete everything out of existence. But wait, there's still space. It still has dimensionality and curvature. There is still time and physical law, even if there are no particles or fields left to be governed by them. Let us delete those too. Let's erase the volume of space, erase time, and erase physical law. Quote, "When we say out of nothingness, we do not mean out of the vacuum of physics. The vacuum of physics is loaded with geometrical structure and vacuum fluctuations and virtual pairs of particles. The universe is already in existence when we have such a vacuum. No, when we speak of nothingness, we mean nothingness, neither structure, nor law, nor plan." End quote. John Archibald Wheeler in Law Without Law, 1983. What are we left with? If we eliminate all the dimensions of space and time, we're left with a zero-dimensional, changeless point. But a point is still a thing. Can we delete that too? Kinds of nothing. So long as we operate from a theory of geometry, we can't define nothingness as anything less than a space of zero-dimensionality. This leaves us with a point. If we want to eliminate the point, we need to define nothingness not as a space of zero-dimensionality, but as something non-geometric. For this, we must define nothingness in terms of some other theory. But any theory we might choose has its own notion of nothing. In other words, nothingness is theory-dependent. For physics, it's no energy, the vacuum. For geometry, it's no dimensionality, a point. For set theory, it's no elements, the empty set. For arithmetic, it's no magnitude, zero. For information theory, it's no information, 0 bits. There is an unlimited number of possible theoretical systems. Does this mean there are also unlimited conceptions of nothing? Quote: "Nothing is simple. Not even nothing." End quote. Bruno Marchal? Might there be a true nothing, one with no laws, principles, nor any theory behind it? Or might every conception of nothing require a theory of things in order to declare that there are none of them? Rules for nothing. We are called for absolute nothingness, neither structure, nor law, nor plan. But is this kind of absolute nothing achievable? For instance, the law of identity holds that for any A equals A. Without such a rule, there would be nothing to ensure that nothing stayed nothing, and didn't later become equal to something. For nothingness to persist, the rules of logic must apply. Further, if nothingness is the state where 0 things exist, then the rules of arithmetic must also hold to ensure that 0 equals 0 rather than 0 equals 1. For there to remain no things requires some minimum set of laws. There might be no things as such, but the idea of no laws seems incompatible with there being and remaining no things. Quote: "In the beginning, there was only truth, logic and their relation. No possible reality can do without them." C.W. Ryushkin, Four-Dimensional Reality Continued, 2018. If there were no logic, what logic or reason ensures that nothing comes from nothing? If there were no laws, what law or principle would prohibit the spontaneous emergence of a universe? The trouble with nothing. Can we define nothing in a way that suppresses all forms of existence? That is, to not only have no things, but an absolute nothingness, a nothingness of no objects, neither abstract nor concrete, no properties, no laws, no principles, and no information content. Or is this a fool's errand? One that leads to a logical inconsistency and thus an impossibility. Might nothingness be, in some sense, unstable? If absolute nothingness can be shown to be an impossible dream, it will advance us on our path to discover the reason for existence. It might even reveal some self-existent or necessarily existent thing. Properties of nothing. Anytime we delete something from reality, we leave something else in its place. When we deleted matter, we created a vacuum. When we eliminated light, we created darkness. When we removed heat, we created cold. When we deleted space, we created a point. Quote: "The idea of nothingness has not one jot more meaning than a square circle. The absence of one thing always being the presence of another, which we prefer to leave aside because it is not the thing that interests us or the thing we were expecting. Suppression is never anything more than substitution, a two-sided operation which we agree to look at from one side only, so that the idea of the absolution of everything is self-destructive, inconceivable. It is a pseudo-idea, a mirage conjured by our own imagination." Henri Bergson in The Two Sources of Morality and Religion, 1935. If every deletion is a substitution for something else, then a pure nothing, devoid of any properties whatever, is impossible. So while we might succeed in removing all material things from reality, we could not remove all properties from reality. The existence of properties appears inescapable. Nothingness of any kind will always have some description and properties, even when it's just a cold, dark, empty vacuum. But how far can we go in eliminating properties? For instance, if we define nothingness as the empty set from set theory, what properties would remain? Temperature has no meaning for a set. Would any properties remain for such a nothing? Properties of zero. Every conception and definition of nothing contains at its heart 0. For any conception of a thing, nothing will always be zero of them. The vacuum, zero energy. Geometry, zero dimensionality. The empty set, zero elements. Arithmetic, zero magnitude. Information theory, zero bits. If zero is a universal property of nothing, we must ask, what are the properties of zero? What does zero bring to the table of reality? Zero has many properties. It's even, it's the additive identity, it's the only number that's neither positive nor negative. It's the number of elements in the empty set and the number of even primes greater than 2. In fact, zero has more properties than we could list if we recruited all the atoms in the observable universe to serve as paper and ink. This effort is doomed because zero's properties are infinite in number. Zero's factors couldn't be listed, as zero has infinitely many of them. Every number evenly divides zero and hence is one of zero's factors. Aside from zero's factors, we could list infinite trivial properties of zero. Zero is the difference between 1 and 1, and it's the difference between 2 and 2, and it's the difference between 3 and 3, and so on. But there are also an infinite number of non-trivial properties of zero. Some are even beyond the understanding of today's mathematicians. As an example, mathematicians have for centuries wondered: are there even numbers greater than 2 that aren't the sum of 2 primes? This question is known as Goldbach's conjecture after Christian Goldbach, who posed it in 1742. Nearly 3 centuries later, it remains unsolved. Between 2000 and 2002, a $1 million prize was offered to anyone who could answer this question. All this money to settle a question about a property of zero. To decide, is zero the number of exceptions to Goldbach's rule? We now see why nothing is simple. Not even nothing. All definitions of nothing include the concept of zero. Far from being simple, zero is an object of unlimited complexity. An explosion of entities. Can zero exist in isolation, completely alone from other numbers? Or do relationships between numbers make them inseparable? Zero's properties reference other numbers. And each of these numbers carries its own set of properties and relations to the other numbers. Are the properties of 1 any less real than the properties of 0? Perhaps in a reality having no things, 1 is meaningless. In a reality containing nothing, there are no things as such, at least no material things. But in such a nothing, there is an abstract thing, 0. 0 reflects the number of material things to count. But how many abstract things are there to count? There is at least 1. The one number that exists to define the number of material things is 0. But if we have one number and it is one thing to count, now another number exists, 1. We then have 0 and 1 together as the only numbers. But now we have 2 numbers. Now 2 exists. This is how numbers are defined in set theory. Within set theory, each number is formed as the set of all previous sets. The process starts with the empty set which contains 0 things. 0 equals the empty set. 1 equals the set of 0. 2 equals the set of 0 and 1. 3 equals the set of 0, 1, and 2. 4 equals the set of 0, 1, 2 and 3. It seems once a single abstract number is admitted, each next number comes to life as the count of the abstract numbers that preceded it. Is there any way to stop the proliferation of infinite abstract entities? If 0 exists by virtue of there being 0 things to count, then on that basis, shouldn't every number have the same right to exist by virtue of being the number of preceding numbers there are to count? Quote: the existence of any number, in virtue of its properties, entails the existence of all the others, i.e. a system of mathematics couldn't exist bereft only of the number, say, 42, and the existence of any number, in virtue of the full set of its properties or structural relationships, entails the existence of every other number. End quote. David Pearce in Why Does Anything Exist? 1995. Set theory and building up numbers from the empty set are modern ideas. They appeared around the turn of the 20th century. Yet the idea of numbers giving rise to themselves goes back much farther. Quote, the Tao gives birth to 1. 1 gives birth to 2. 2 gives birth to 3. 3 gives birth to all things. Lao Jia in chapter 42 of Tao Te Ching, circa 600 BC. A true nothing. Whenever we specify or define nothing, we invoke theories and concepts which, in turn, lead to properties and abstract entities. But what if we forego even specifying nothing? Might this be a path to achieve absolute nothingness? A true nothing, having no things, no objects, no definitions, no properties, no abstract entities, no concepts, no sets, no numbers, no set theory, no mathematics, no specifications, no information. Avoiding all this, we have no theories of any kind. We are left with a plain and simple, pure, unadulterated nothing at all. But again, this leads to trouble. There's a problem with this kind of nothing. A nothing of no information is identical to everything. Quote, we note that the collection of all possible descriptions has zero complexity, or information content. This is a consequence of algorithmic information theory, the fundamental theory of computer science. There is a mathematical equivalence between the everything, as represented by this collection of all possible descriptions, and nothing, a state of no information. End quote. Russell Standish in Theory of Nothing, 2006. At first this sounds counterintuitive, if not outright wrong. Yet this consequence is something we intuitively understand in other contexts. Let's review 3 such cases: Unsculpted Marble, an unsent email, and the Library of Babel. Each demonstrates an equivalence between the nothing of no specification, and the everything of all possibilities. Unsculpted Marble. Before marked by a sculptor's chisel, a block of marble contains every figure, or at least every figure fitting the dimensions of the block. Michelangelo's Pieta was in the block before he uncovered it. It was there with all the other figures. To bring forth the Pieta alone, required the addition of information. Michelangelo had to uniquely specify the Pieta from among the set of all possibilities. Quote, there is a beautiful angel in that block of marble, and I am going to find it. All I have to do is to knock off the outside pieces of marble, and be very careful not to cut into the angel with my chisel. In a month or so you will see how beautiful it is. George F. Pentecost in The Angel in the Marble, 1883. This specification requires adding information to the block, by way of chisel marks. It is only in the absence of this information, in the absence of any chisel marks, that all possible figures remain. In this sense, information is subtractive rather than additive. When information specifies, it eliminates from the pre-existing infinite set of possibilities. Absent such information, all possibilities remain. An unsent email. You are at your desk, awaiting an important email from your boss. Before this message arrives, you know nothing about the contents of this email. You are in a state of having no information. But there is one thing you know before the email arrives: the email will be one message from among the infinite set of possible emails. Only after the email arrives in your inbox do you learn which from among the infinite set of messages the boss chose to send you. But consider the case where instead of sending a single email, the boss sent you every possible email. Would you be able to learn anything from these infinite messages about what your boss wants? The lack of specification in the infinite set of messages is equal to the lack of specification that existed prior to receiving anything. Both states are equivalently unspecified. Therefore, both represent states of complete ignorance, and a state of having zero information. Having every message is as informative as having no message. The Library of Babel. One of the best illustrations of the uselessness of all information comes from Jorge Luis Borges's concept of a total library, described in his short story The Library of Babel. This library is described as follows. Quote, "The universe, which others call the library, is composed of an indefinite and perhaps infinite number of hexagonal galleries, with vast air shafts between, surrounded by very low railings. From any of the hexagons one can see, interminably, the upper and lower floors. There are 5 shelves for each of the hexagon's walls, each shelf contains 35 books of uniform format, each book is of 410 pages, each page of 40 lines, each line of some 80 letters which are black in color. This thinker observed that all the books, no matter how diverse they might be, are made up of the same elements, the space, the period, the comma, the 22 letters of the alphabet. He also alleged a fact which travelers have confirmed: in the vast library there are no 2 identical books. From these 2 incontrovertible premises he deduced that the library is total and that its shelves register all the possible combinations of the 20-odd orthographical symbols." Jorge Luis Borges in The Library of Babel, 1941. From the provided information, we can calculate the number of books in this library. This total library contains every possible 410-page book, representing every possible arrangement of 25 characters. Each page, with 40 lines and 80 characters, contains 3,200 characters. Each book, with 410 pages, contains 410 times 3,200 or 1,312,000 characters. With an alphabet of 25 characters, this gives 25 to the 1,312,000th power possible books. This number is 25 multiplied by itself over 1,000,000 times. To put its magnitude in context, the number of atoms in the observable universe is only 25 to the power of 57, or 25 multiplied by itself 57 times. This library is a great treasure. For in this library we can find every book, article, poem, and novel ever written, or that could be written. We'll find descriptions of every scientific theory, from Newton's Principia, to Einstein's relativity, to the presently unknown theory of quantum gravity. We'll find blueprints to world-changing technologies not yet invented based on principles not yet discovered. This library possesses the greatest works of literature, the complete works of Shakespeare, Dickens, and Tolstoy. It also has every work yet to be written, the completed Game of Thrones series, as well as the unfinished works of Tolkien, Hemingway, and Twain. The library has the untold histories of every civilization, including civilizations now lost to time. It has the contents of every scroll burned in the fire of Alexandria. The library has biographies of every person who's ever lived, and even biographies of those yet to be born. What could be more valuable than this boundless trove of information, with its complete knowledge, its answers to every mystery, and its articulated solutions to every problem? This is where the equivalence between all information and no information rears its ugly head. It renders the library worthless. There are issues with this library. To start, for every valid theory, technology, history, and autobiography in the library, there are countless others that are subtly wrong, inaccurate, or utterly bogus. Worse, Finding any book with more than a few grammatically sensible words is next to impossible. Most books are pure gibberish, or babble, indistinguishable from random sequences of characters. A typical page from a book in the Library of Babel contains English-sounding words, but these are no more frequent than random chance predicts. Perhaps all hope is not lost. Since this library contains every possible book, surely this library contains books that serve as indexes to find all the other meaningful and sensible books in the library. But this dream is also impossible. Given the number of books, it's impossible to uniquely reference any other book with a descriptor shorter than the length of the book. Thus it takes all 410 pages to reference a specific book in this library. Due to its completeness, the library itself is the most compact catalogue of all the books in the library. In other words, a card catalogue of the library would be the library itself. What if we organize the books somehow, such as by sorting them in alphabetical order? Then finding any particular book would be easy. This too suffers from a pathological breakdown. While this makes it easy to find any particular book, the difficulty shifts from finding the book to deciding which book we want to find. This is a consequence of the library having every possible book. As one seeks a book of interest, one is faced with 25 choices, to choose which of the 25 characters is next in the content of the book we seek. During the search, the seeker must choose each next letter, and must do this for all 1,312,000 characters in the book. Thus, finding a book in this library is as difficult as writing the book in the first place. In a way, we already have access to this library, as we are already free to put down any sequence of characters we want, and thus find a book that is already present somewhere in this total library. Thus, this library provides no new knowledge or information. Its set of all books is as helpful to us as if it had no books. And so a total library offers nothing. It's equivalent to having no information at all. You can explore this frustrating enigma of the Library of Babel. Jonathan Basile created an online version at libraryofbabel.info. Everything from nothing. Information theory reveals the equivalence between the totality of all information and the nothingness of zero information. Both lack any specification. Both are completely uninformative. Both contain within them the complete and infinite set of every possibility. We've seen this equivalence firsthand. We saw it in the unsculpted block of marble, in the unsent email, and in the Library of Babel. So is a nothing of no specification, a nothing or an everything. Less information, more reality. How much information is in the Library of Babel? To determine this, we need only consider what is the shortest description that can generate the content of the library. For instance, a library containing one of each possible 410-page book with 3,200 characters per page and a fixed alphabet of 25 characters. The preceding description for the library is 125 characters long. There could be shorter descriptions, but this sets an upper bound for the information content of the Library of Babel. It takes next to no information to describe the vast Library of Babel. Paradoxically, there's more information in a single page from a single book in the library, than in the entire library itself. How could this be? How can there be less information in the library as a whole than there is in a single book or page from the library? This is a consequence of algorithmic information theory, which includes the science of data compression. It reveals that it is simpler, in terms of needing a shorter description, to generate every book in the library than it is to generate only a single book, or a single page of a book in the library. A shorter, less specific, and more general description casts a wider net. A single book requires 1,312,000 characters. The Library of Babel requires 125 characters. All possible books requires 18 characters. The description all possible books needs fewer characters than the description of the Library of Babel, but it defines a much larger set of books. In fact, it defines an infinite set of books, of all possible lengths and character sets. The Library of Babel, though vast, was still finite. Might the same apply to our universe and reality? To describe one universe like ours requires a vast amount of information. It requires specifying not only the physical laws, but also the position, direction, and speed of every particle in the universe. This is estimated to require on the order of 10 to the power of 90 bits. Yet to specify every possible universe of our kind, a multiverse of every possible arrangement of particles ruled by our laws of physics, needs much less information. Such a multiverse requires only the information to define the physical laws, particle types, fundamental forces and constants of nature. This can be done in just a few pages of equations. Describing our specific universe is like describing a specific book from the Library of Babel. It needs more information than the library itself. In theories such as the string theory landscape, the constants of nature are not specified by the theory, leading to an even greater multiverse consisting of every possible universe having every set of possible values for the constants of nature, for example different values for things like the electron mass, and the strength of electromagnetism. There are reasons to suspect this, or something like it is true. For one, it explains why laws of physics and constants of nature appear fine-tuned for the emergence of life. C. Was the universe made for life? This description of a string theory landscape needs less information. It might save a page by not having to include the 30-some-odd constants of nature. And yet, it describes a vastly larger multiverse. The observable universe with particle velocities, physical constants and physical equations requires 10 to the 90 bits or about 10 to the 85 pages to specify. The quantum multiverse with physical constants and physical equations requires approximately 144,000 bits or about 6 pages to specify. The string theory landscape with its physical equations requires approximately 120,000 bits or about 5 pages to specify. All physical possibility requires 0 bits. What happens when the length of reality's description goes to 0? This would leave the equations themselves unspecified, implying an even greater multiverse. This multiverse includes universes not just of every arrangement of matter, nor universes of every set of constants, but universes ruled by every kind of physical equations. Quote, if all possible string vacua, spacetime geometries, masses of elementary particles and interaction strengths, and laws and bylaws of physics are realized, then all possible descriptions are satisfied. This is equivalent to 0 information. End quote. David Pearce in Why Does Anything Exist? 1995. Thus, to specify all possible physical laws, all possible physical constants, for all possible universes, needs no information at all. Might we inhabit such a nothing? This is the thesis of Russell Standish's 2006 book Theory of Nothing. Standish believes our universe, with its seemingly vast quantity of information, is something like a book in the Library of Babel. We would then be denizens of nothing, occupying a place within a total reality which altogether amounts to 0 information. Such a reality, one of 0 information, is the simplest state of existence. It's simpler than an empty vacuum or a geometrical point, as these both need a non-zero amount of information to describe. Necessary existence. We've attempted but frustratingly failed to define a true nothing. When we tried to specify a nothing, whether as a vacuum, a point, or an empty set, we inevitably invoke properties, abstract entities, the number 0 and the infinitude of numbers and their relationships. Furthermore, this specification is not an absolute nothing, as it requires reality to have a non-zero amount of information to specify it. Alternatively, if we attempt a nothing of zero information and zero specification, we get a total reality containing all possibility. Neither approach succeeds in bringing about absolute nothingness. Moreover, these approaches rely upon and assume the validity of logical principles and consistency. No reality, not even a nothing, appears possible without laws and principles of logic. And so the goal of the philosopher's nothing, the neither structure, nor law, nor plan kind of true nothing at all, seems an impossible dream. The nothings we attempt break down and lead to somethings. With no structure, there are zero structures. This introduces zero, and with it the structure of all numbers and their interrelations. With no law, there are no restrictions on what can or cannot exist, nor any law to prevent things spontaneously popping into existence. With no plan, there is no information, which is equivalent to a totality. Inspired by his discovery of binary numbers, Leibniz wrote to the Duke of Brunswick in 1679 suggesting a design for a coin. He titled it Imago Creationis, or the image of creation. Its motto reads, quote, Omnibus ex nihil ducendis sufficit unum. For producing everything out of nothing, one principle is enough. End quote. Gottfried Wilhelm Leibniz in Letter to Duke, 1679. If a true and absolute nothing is impossible or unstable, does this mean there must be self-creating or self-existent things? Can a thing exist out of logical necessity, because its absence is impossible? What might the nature of such things be? A self-existent thing. If something did not emerge out of nothing, then there's only one other possibility, that there is something that has always existed. In other words, nothingness is not the default state of reality. Quote, It is extraordinary that there should exist anything at all. Surely the most natural state of affairs is simply nothing, no universe, no God, nothing. But there is something. Richard Swinburne in Is There a God? 1996. Given that something exists, it either came from nothing or else something has existed from the beginning. The existence of this thing is somehow necessary. It existed without any preceding cause. This, we also find contrary to intuition. It's strange because everything we are familiar with can trace its existence to some earlier cause. Manufactured things are made by people, or by machines that were made by people. Life comes from other life. Things not created by humans or other life, like rivers and mountains, are created by natural forces acting on matter. It seems to defy reason for a thing to exist without a cause. And yet, we know the universe exists. The universe either came from some preceding cause, or else the universe has always existed, is self-existent, or self-creating. There is no third option. If the universe is not the end of this causal chain, then something else is. Therefore we must accept some things are self-creating, come out of nothing, or are self-existent. Let's call such a thing causeless. Existing without cause. Take anything that exists, the chair you're sitting in, your conscious thoughts, the Eiffel Tower. For the purposes of the reasoning, it doesn't matter what thing we start with. Given that this thing exists, there are two possibilities: either that thing was caused or it was not caused. If a thing has no cause, then it is causeless. Otherwise, the thing has a cause and its existence is owed to some other thing. If we follow the chain of causality back towards an ultimate root cause, there are three possibilities. 1. First cause, the chain of causality comes to an end in a first cause. 2. Infinite regression, the chain of causality continues forever. 3. Causal loop, the chain of causality forms a closed cycle, or a loop. These represent all possibilities. The trace either ends, a first cause, or it continues forever. If it continues forever, it forms an infinite chain that's either open, an infinite regression, or closed, a causal loop. In all three cases we find something that has always existed, either the first cause, the infinite chain itself, or the causal loop itself. This thing, which has always existed, we can describe as causeless. First cause. If when tracing back through the series of causes we happen upon something causeless, then our existence results from a first cause. Leading cosmological theories, such as the Big Bang and cosmic inflation, posit that the universe is not infinitely old, but rather underwent an abrupt event where it came into existence. That our universe has a point that may be marked as a beginning leaves open the possibility that there is a preceding cause for our universe. Another possibility is that the universe is its own cause, emerging as a random quantum fluctuation allowed by laws of physics. Many religions speak of the first cause as a divine act of creation. In such a case, God would be the first cause. Yet some other non-theistic object could as well be responsible for our existence. If the universe is not eternal, we should look for some reason for the sudden appearance of the universe, to explain how it could arise by itself, be self-existent, or be the product of some prior cause. Infinite regression. If our universe has an eternal history, or if it belongs to a reality having an eternal history, then we exist due to an infinite regression. A number of scientific theories propose that our universe is eternal. Prior to wide acceptance of the Big Bang, the steady-state model was popular. It proposed that the universe is eternally expanding with new matter perpetually created to fill the void in the newly made space. Since the acceptance of the Big Bang, various new models suppose that the Big Bang is itself part of an eternal succession of Big Bangs. Roger Penrose's conformal cyclic cosmology supposes that the heat death of our universe could appear as a new Big Bang in the next eon. Lee Smolin proposed cosmological natural selection wherein a new universe spawns every time a black hole forms. Accordingly, if the laws mutate, he suggests that universes might even evolve towards having laws that maximize the production of black holes. Sean Carroll notes that the equations of quantum mechanics, unlike those of general relativity, permit physicists to calculate eternally into the past or future. With a theory of quantum gravity, we could in principle predict backwards to times preceding the Big Bang. Quote, "The Schrödinger equation has an immediate, profound consequence. Almost all quantum states evolve eternally toward both the past and the future. Unlike classical models such as spacetime in general relativity, which can hit singularities beyond which evolution cannot be extended, quantum evolution is very simple. If this setup describes the real world, there is no beginning nor end to time." Sean Carroll in Why Is There Something, Rather Than Nothing? 2018. According to ancient legends, the world rests on the back of a cosmic turtle. When asked what the cosmic turtle rests on, a common response is, it is turtles all the way down, an infinite regression. If an infinite regression is true, there is no ultimate cause. However, we might still look for an ultimate explanation for the chain of causes. Causal loop. It might be that our existence is part of an infinite series, but one that repeats forever. If true, we are stuck in a never-ending causal loop. The hypothesized Big Bounce is an example of a cyclic cosmology. In 1922, Alexander Friedman applied Einstein's equations of general relativity to the universe as a whole. He found that for certain values of the density of the universe and the cosmological constant, the universe will expand for a period of time, slow down, and eventually recollapse. In his 1923 book, The World as Space and Time, Friedman speculates that the collapse, or big crunch, could rebound, in a big bounce, causing a new Big Bang. The process could repeat forever. The idea of cyclic cosmology has appealed to many scientists, including Georges Lemaitre, Richard Tolman, George Gamow, William Bonor, Hermann Zanstra, and Robert Dick, among others. Quote, "We can now ask ourselves two important questions. Why was our universe in such a highly compressed state, and why did it start expanding?" The simplest and mathematically most consistent way of answering these questions would be to say that the big squeeze which took place in the early history of our universe was the result of a collapse which took place at a still earlier era. And that the present expansion is simply an elastic rebound which started as soon as the maximum permissible squeezing density was reached. End quote. George Gamow in The Creation of the Universe, 1952. Cyclical cosmologies can be found in many religions. For example, there is the concept of the Wheel of Time in the Dharmic religions. Quote, "The most elegant and sublime of these is a representation of the creation of the universe at the beginning of each cosmic cycle, a motif known as the cosmic dance of Shiva. The god, called in this manifestation Nataraja, the dance king, has 4 hands. In the upper right hand is a drum whose sound is the sound of creation. In the upper left hand is a tongue of flame, a reminder that the universe, now newly created, will billions of years from now be utterly destroyed." End quote. Carl Sagan in Cosmos, 1980. But cyclic models, lacking observational evidence and theoretical support, remained on the periphery of cosmology. In 1998, observations revealed the expansion of the universe was not slowing, but accelerating. This seems to rule out a future collapse. The driver of this acceleration, dark energy, remains little understood. If it is constant, the expansion will continue forever. But in some theories, it varies with time, and so a later collapse may be possible. Cyclic models have seen a revival. In 2001, Justin Horry, Bert Overath, Paul Steinert and Neil Turok proposed the ekpyrotic universe. This idea marries string theory and cosmology to give a model where periodic brane collisions trigger cycles of big bangs and big crunches. If our universe is part of a causal loop, no beginning or end is identifiable. But what got it started? Did one of the succession of states spring forth out of nothing, or might the loop have always existed? The nature of uncaused things. Given that reality exists, we know there must be an entity that is causeless. What is it about causeless entities that makes them existent? If a first cause, how did it bring itself into existence? If an infinite regression or causal loop, how did it come into being? Might it exist out of logical necessity? Or is it a result of chance? Or might it exist simply because it can exist, and nothing forbids it? Tracing causes backwards can tell us where the previous state came from, but it won't answer where the chain or loop itself came from. Quote, "Some believe that, if all events were caused by earlier events, everything would be explained. That, however, is not so. Even an infinite series of events cannot explain itself. We could ask why this series occurred, rather than some other series, or no series." Derek Parfit in Why Anything? Why This? 2008. What we are looking for is not a cause, but a reason, an explanation. For in the cases of the loops or infinite regression, we can always find an earlier cause, but may never reach a satisfactory reason. Quote, "For the question to be properly, fully answered, we need a sufficient reason that has no need of any further reason, a because that doesn't throw up a further why, and this must lie outside the series of contingent things, and must be found in a substance which is the cause of the entire series. It must be something that exists necessarily, carrying the reason for its existence within itself, only that can give us a sufficient reason at which we can stop, having no further why. Question taking us from this being to something else. End quote. Gottfried Wilhelm Leibniz in The Principles of Nature and Grace, based on reason, 1714. If we seek a final because that puts an end to any further whys, we must find something that we can show must exist. Not only must this thing exist, but we must also show how this thing can account for the reality we experience, only then will we have succeeded in our quest. Candidates for self-existence. Throughout history, philosophers, scientists and religions have suggested candidates for self-existence. These causeless entities generally fall into one of 7 categories. 1. Logic. 2. Truth. 3. Numbers. 4. Possibility. 5. The universe. 6. A higher plane. And 7. Consciousness. Let's review each candidate, and its merits for self-existence. Afterwards, we will consider whether that entity could further serve as an ultimate explanation, a self-existent starting point from which the rest of reality emerges as a direct consequence of that thing. Logic. Some suppose rational principles, like the laws of logic, are self-existent. Unlike physical laws, logical laws have an air of inevitability to them. These are laws such as the law of identity: things are identical to themselves, for example A equals A. The law of the excluded middle: statements are either true or not true. The law of non-contradiction: no statement is both true and false. These are laws that seem inevitable, and necessary in any reality, as it's hard to imagine any reality where logical laws would not hold. If logical laws apply in all universes and all possible realities, they represent universal laws, applying everywhere and to everything. If we can say laws of physics exist because all matter in our universe adheres to physical laws, then could we say laws of logic exist, because all things in all possible realities adhere to these logical laws? If so, then laws of logic are self-existent. They are necessary even in a reality of no things, as logical laws ensure nothing equals nothing. Quote, if I ask myself why bodies or minds exist rather than nothing, I find no answer, but that a logical principle, such as A equals A, should have the power of creating itself, triumphing over the naught throughout eternity, seems to be natural. End quote. Henri Bergson in Creative Evolution, 1907. This idea, that logical law and rational principles have eternally existed, predates modern philosophers. It's a cornerstone belief in Taoism. Quote, there was something formless and perfect before the universe was born. It is serene, empty, solitary, unchanging, infinite, eternally present. It is the mother of the universe. For lack of a better name, I call it the Tao. Lao Jia in chapter 25 of Tao Te Ching, circa 600 BC. Tao translates as the way, principles, and natural order. A similar sentiment is expressed in Christianity. The Gospel of John begins, quote, in the beginning was the Word, and the Word was with God, and the Word was God. Gospel of John, chapter 1 verse 1, 100 AD. The term word is a translation of verbum in Latin, which is a translation of logos in Greek. Logos has a deep and rich meaning. Aside from word, logos also means reason, principles, and rational law. Logos is the root from which we get the word logic. It is also the origin of the suffix logi, as in biology, geology and psychology, where it means the principles, explanation, and story thereof. Quote, if however he be admitted to exist apart from matter in virtue of his character as a principle and a rational law, logos, God will be bodiless, the creative power bodiless. Plotinus in the Ennead 6, 1, 26, 270 AD. In Chinese Bibles, logos has been translated as Tao. In this way, both Taoist and Christian ideas suppose that the Tao/logos, order, reason, principles, logic, rational law, exists prior to the material universe. Truth. Some believe that truth is causeless. There seems to be some essential difference between 0 is even and 0 is odd, only one of them is true. Did anything make it so? When did this statement become true? Did it require a human mind to conceive of it as being true, or has it always been true? Might this property of truth have an independent, and necessary existence? If logical laws apply universally, then any well-formed statement is either true or false. The law of non-contradiction says a statement can't be both true and false. The law of excluded middle says a statement must be either true or false, there is no middle ground. Thus, if logical laws apply to everything, they apply to all statements, forcing on them the objective property of being either true or false. As Derek Parfit said, some truth is logically necessary when its denial leads to a contradiction. Accordingly, the truth that 0 is even would exist before humans proved it. It would be true before it was first spoken. Presumably, it would be true absent a universe of things, for even in the case 0 things exist, it remains true that an even number of things exist. Quote, when we imagine how things would have been if nothing had ever existed, what we should imagine away are such things as living beings, stars and atoms. There would still have been various truths, such as the truth that there were no stars or atoms, or that 9 is divisible by 3. We can ask why these things would have been true. And such questions may have answers. Thus we can explain why, even if nothing had ever existed, 9 would still have been divisible by 3. There is no conceivable alternative. End quote. Derek Parfit in Why Anything? Why This? 2008. Ultimately, nothing is responsible for creating this truth. Truth exists out of its own necessity. It has always existed and could never not exist. The idea of the primacy of truth is very old. It can be found in many religions, some of which draw an equivalence between God and truth. In the 3,000-year-old religion of Zoroastrianism, it is said that Asher, meaning truth and order, is the divine law behind all things. Quote, Iran, as India, presents us with a term which has had to signify first of all true statement, that this statement, because it was true, had to correspond to an objective, material reality, and that, as the discourse did, this reality must embrace all things, and, finally that one recognized in it a great cosmic principle since all things happen according to it. End quote. Jacques Duchesne Guillermin in Heraclitus and Iran, 1963. In the Book of Psalms chapter 31 verse 5, God is called the God of truth. In the Quran, Al-Haq, meaning the truth, is one of the 99 names of God. Similar ideas are found in Dharmic religions. The Mool Mantar, or root mantra, is the most important verse of the Sikh religion. It begins, there is one creator, whose name is truth and is described as timeless, beyond birth or death, and self-existent. In the Brahma Samhita, a Hindu prayer book, the primeval Lord Govinda is described as the indivisible, infinite, limitless, truth. Quote, if it is possible for the human tongue to give the fullest description of God, I have come to the conclusion that God is truth. End quote. Mahatma Gandhi in All Men Are Brothers, 1953. Numbers? Some speculate that numbers, or their relationships, are self-existent. If truth has an independent existence, this truth includes the infinite truths describing all true relationships between the numbers. These include arithmetical statements, such as 2 is even, 7 is prime, 1 is greater than 0, 2 plus 2 equals 4, n times 0 equals 0, and that the square root of 9 is 3. Truths concerning the numbers are boundless. Might this infinite truth provide a scaffolding and structure to all the numbers? And if there is nothing more to numbers than their properties and relations, then might numbers, in some sense, really exist? It's been said, math is the science we could still do if we woke up tomorrow and there was no universe. The idea that math holds some claim to reality is known as mathematical realism, or Platonism. It's believed by many, if not most, mathematicians. Quote, "It is an idea that many mathematicians are comfortable with. In this scheme, the truths that mathematicians seek are, in a clear sense, already there, and mathematical research can be compared with archaeology. The mathematician's job is to seek out these truths as a task of discovery rather than one of invention." Roger Penrose in The Big Questions, What is Reality? 2006. But can number relations have any reality in the absence of things? If 0 things exist, it would have to be true that 0 not equal 1, and also that 0 not equal 2, and true that 0 not equal any other number. So even with no things, an infinite number of arithmetical relations are needed to avoid contradiction and preserve a nothing of 0 things. Quote, "If all things were absent, would 2 and 2 make 4 be a non-reality, remaining like that until at least 4 things had come to exist? Presumably the answer must be no." John A. Leslie and Robert Lawrence Kuhn in The Mystery of Existence, 2013. This idea that numbers have an independent existence is ancient. It can be traced to some of the earliest records of human thought. It was taught by ancient philosophers, and is found in the oldest religious texts. Taoism, for instance, sets the existence of numbers as prior to things. Quote, "The Tao gives birth to 1. 1 gives birth to 2. 2 gives birth to 3. 3 gives birth to all things." Lao Jia in chapter 42 of Tao Te Ching, circa 600 BC. The Greek mathematician Pythagoras taught all things are number. Quote, "Pythagoreans applied themselves to mathematics, and were the first to develop this science, and through studying it they came to believe that its principles are the principles of everything." Aristotle in Metaphysics, circa 350 BC. Pythagoras was the first to propose that the motions of the planets are governed by mathematical equations, which he called the harmony of the spheres. When Newton discovered his law of universal gravitation some 2,000 years later, he credited Pythagoras for the discovery. Across times, mathematicians have described a seemingly divine connection between mathematics and reality. Quote, "Geometry, which before the origin of things was coeternal with the divine mind and is God himself, for what could there be in God which would not be God himself, supplied God with patterns for the creation of the world, and passed over to man along with the image of God." Johannes Kepler in The Harmony of the World, 1619. Quote, "From these considerations it is now wonderfully evident how a certain divine mathematics or metaphysical mechanics is employed in the very origination of things." Gottfried Wilhelm Leibniz in On the Ultimate Origination of Things, 1697. Quote, "To all of us who hold the Christian belief that God is truth, anything that is true is a fact about God, and mathematics is a branch of theology." An old Greek, a French child, and a self-taught Indian, each finds for himself the same theory of geometrical conics. The simplest and therefore the most scientific way of describing this, is that they have discovered, not created, a geometry that exists by itself eternally, the same for all, the same for teacher as for taught, the same for man as for God. The truth that is the same for man as for God is pure mathematics. Hilda P. Hudson in Mathematics and Eternity, 1925. Possibility. Some speculate that simply not being impossible is sufficient for being actual. If true, then every possible object, structure, and entity exists. What then is impossible? At a minimum, we can say self-contradictory things. For example, square circles, married bachelors, triangles with 5 sides and so on. We might also include things proven to not exist, odd numbers evenly divisible by 2, a largest prime number, a sixth Platonic solid. If consistency and provability are the requirements for possibility, then possible existence is mathematical existence. As David Hilbert said, mathematical existence is merely freedom from contradiction. The idea that all possible things exist has enjoyed many names. In 1936, Arthur Lovejoy dubbed it the principle of plenitude. In 1981, Robert Nozick named it the principle of fecundity. David Lewis, in 1986, developed it as a theory he called modal realism. In Max Tegmark's 1998 model of multiverses, he called it the mathematical universe hypothesis. Most recently, in 2008, Derek Parfit coined the all worlds hypothesis. If all possible objects are actual, then our universe is just one such possible structure among an infinite, and total, set of all possible structures. Anything that could happen, happens somewhere. Quote, "There are so many other worlds, in fact, that absolutely every way that a world could possibly be is a way that some world is. And as with worlds, so it is with parts of worlds. There are ever so many ways that a part of a world could be. And so many and so varied are the other worlds that absolutely every way that a part of a world could possibly be is a way that some part of some world is." End quote. David Lewis in On the Plurality of Worlds, 1986. Quote, "If the universe is inherently mathematical, then why was only one of the many mathematical structures singled out to describe a universe? A fundamental asymmetry appears to be built into the heart of reality. As a way out of this conundrum, I have suggested that complete mathematical symmetry holds, that all mathematical structures exist physically as well. Every mathematical structure corresponds to a parallel universe." End quote. Max Tegmark in Parallel Universes, 2003. The idea that possibility is sufficient for actuality is not new. Arthur Lovejoy, who wrote about the history of this idea, traced it to 360 BC beginning with Plato's theory of forms. Plato hypothesized a realm containing all possible forms, eternal, perfect, idealizations. We find this idea expressed in a variety of ways throughout history. Quote, "The one is all things and not a single one of them. It is because there is nothing in it that all things come from it, in order that being may exist. The one is not being, but the generator of being." Plotinus in the Enneads 5, 2, 1, 270 AD. Quote, "But to explain more distinctly how from eternal or essential metaphysical truths there arise temporal, contingent or physical truths, we must first observe that from the very fact that there exists something rather than nothing, it follows that in possible things, or in possibility or essence itself, there is a certain need of existence, or so to speak, a claim to exist, in a word, that essence of itself tends to existence." Gottfried Wilhelm Leibniz in On the Ultimate Origination of Things, 1697. Others have linked God's infinite nature to an infinite creation. Quote, "From God's supreme power, or infinite nature, an infinite number of things, that is, all things have necessarily flowed forth in an infinite number of ways, or always flow from the same necessity. In the same way as from the nature of a triangle it follows from eternity and for eternity, that its three interior angles are equal to two right angles." Baruch Spinoza in Ethics, 1677. Quote, "Know thou of a truth that the worlds of God are countless in their number, and infinite in their range. None can reckon or comprehend them except God, the all-knowing, the all-wise." Baha'u'llah in Tablet to Wafa, circa 1885. Quote, "It makes sense that an infinitely creative deity would create other universes, not just our own. For the theist, the existence of multiple universes would simply support the view that creation reflects the infinite creativity of the Creator." Robin A. Collins in Spiritual Information, 2005. The universe? Some say that the universe, or the physical law that enabled it to come into existence, has always existed and so is self-existent. The reasoning is simple. If we know at least one thing is causeless, why not just presume this causeless thing is the universe itself? Quote, "I should say that the universe is just there, and that's all." End quote. Bertrand Russell in Russell-Copleston Debate, 1948. Perhaps there is no reason. It simply is, and has no explanation. Given the universe exists, we know the universe is possible. Perhaps it exists because it is possible, and nothing forbade it from existing. But there are other tracks to follow. Perhaps we can demonstrate that the universe is self-creating. Or that it exists due to some higher law. Modern cosmology made progress along these directions. The theory of cosmic inflation uses general relativity to explain how a tiny quantum fluctuation can inflate into the huge universe we now see. Quote, "Inflation is radically at odds with the old dictum of Democritus and Lucretius, nothing can be created from nothing. If inflation is right, everything can be created from nothing, or at least from very little. If inflation is right, the universe can properly be called the ultimate free lunch." End quote. Alan Guth in Inflation and the New Era of High-Precision Cosmology, 2002. According to the laws of quantum mechanics, the quantum fluctuation that seeded our universe appeared because it was possible, emerging out of nothing but the physical laws themselves. Quote, "Is there any bound to how small the initial universe could be? To my surprise, I found that the tunneling probability did not vanish as the initial size approached zero. I also noticed that my calculations were greatly simplified when I allowed the initial radius of the universe to vanish. This was really crazy. What I had was a mathematical description of a universe tunneling from a zero size, from nothing. And yet, the state of nothing cannot be identified with absolute nothingness. The tunneling is described by the laws of quantum mechanics, and thus nothing should be subjected to these laws. The laws of physics must have existed, even though there was no universe." End quote. Alexander Valenkin in Many Worlds in One, 2006. General relativity and quantum mechanics are the two cornerstone theories of modern physics. From them alone we can explain a self-emerging universe. Quantum mechanics shows how possible fluctuations spontaneously pop into existence. General relativity explains how such a fluctuation could expand exponentially to reach an unfathomable size. See, what caused the Big Bang? But we must wonder, why these laws? What, if anything, is special about them? Who or what anointed these equations with existence? Quote, "What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Stephen Hawking in A Brief History of Time, 1988. The idea that the universe is uncreated, or exists due to some laws, predates the successes of modern physics and cosmology. The ancient Greeks and Romans believed that the material of the universe has always existed, since nothing comes from nothing. Quote, "The first principle is that nothing can be created from the non-existent, for otherwise anything would be formed from anything without the need of seed." End quote. Epicurus in Letter to Herodotus, circa 300 BC. This matter was originally in a state of disorder, or chaos. Quote, "Before the ocean and the earth appeared, before the skies had overspread them all, the face of nature in a vast expanse was naught but chaos uniformly waste." Ovid in Metamorphoses, 8 AD. It was not until a divine craftsman imposed mathematical order on this chaos that the ordered universe, the cosmos, appeared. In religions with past eternal cosmologies, the universe is believed to be causeless. Jainism explicitly says the universe was not created. Quote, "The doctrine that the world was created is ill-advised and should be rejected. If God created the world, where was he before the creation? If you say he was transcendent then and needed no support, where is he now? How could God have made this world without any raw material? If you say that he made this first, and then the world, you are faced with an endless regression. If you declare that this raw material arose naturally, you fall into another fallacy, for the whole universe might thus have been its own creator, and have arisen quite naturally." End quote. Jinasena in Mahapurana, 898 AD. A higher plane. Some suppose our universe exists on account of a higher plane and that this higher plane, rather than the universe, is self-existent. There are many conceptions of what this higher plane of reality is. Some describe this plane as a cause of being, be it God, a creator, divine will, a first cause, or an unmoved mover. Others describe it as a source of being, the mind of God, the One, or the Tao. Still others describe it as a ground of being, the Absolute, the All, or what Hindus call Brahman. Not all theories of higher planes of existence need be supernatural. There are also naturalistic descriptions of higher realities. In multiverse theories, a higher reality contains our universe among others. In brain cosmology, our universe is caused by collisions in a literal higher dimension. In the simulation hypothesis, our universe is the result of computations occurring in a more fundamental reality. See, are we living in a computer simulation? Though these theories deal with phenomena that are beyond the nature of our universe, and hence supernatural, evidence is accumulating for some of these higher realms. Quote, "Every experiment that brings better credence to inflationary theory brings us much closer to hints that the multiverse is real." Andre Lind in Interview, 2014. Quote, "Various theories imply that various types of parallel universes exist, so that by modus ponens, if we take any of these theories seriously, we're forced to take seriously also some parallel universes. Parallel universes aren't a theory, but predictions of certain theories." Max Tegmark in Our Parallel Universes Unscientific Nonsense. 2014. The idea of a pre-existent cause, source, or ground of being, one that's external to and beyond our universe, is as old as religion itself. Quote, "By means of the higher knowledge the wise behold everywhere Brahman, which otherwise cannot be seen or seized, which has no root or attributes, no eyes or ears, no hands or feet. which is eternal and omnipresent, all-pervading and extremely subtle, which is imperishable, and the source of all beings. Mundaka Upanishad Chapter 1 Verse 6, circa 800 BC. Quote, "In the beginning God created the heavens and the earth." Genesis chapter 1, verse 1, circa 600 BC. Consciousness. Some posit that consciousness is self-existent. If true, consciousness could be the cause of a universe that exists only in appearance. The idea seems strange, but we must admit all knowledge of existence comes to us through experiences that exist in our conscious minds. This fact hasn't escaped the attention of scientists. Quote, "It is difficult for the matter-of-fact physicist to accept the view that the substratum of everything is of mental character. But no one can deny that mind is the first and most direct thing in our experience, and all else is remote inference." End quote. Arthur Eddington in The Nature of the Physical World, 1927. Quote, "I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing, postulates consciousness." End quote. Max Planck in Interviews with Great Scientists, 1931. The relation between mind and matter perplexes scientists to this day. It leads to philosophical conundrums like brains in a vat, Boltzmann brains, and the simulation argument. All of which suppose that perceived reality is an illusion, a byproduct of a deluded mind. It's also led physicists to propose theories where conscious minds play a fundamental role in shaping reality as we see it. Physics, after all, is fundamentally about experiences. Physics is the science of predicting future observations from prior observations. In 1970, Heinz-Dieter Zeh proposed the many-minds interpretation of quantum mechanics, which proposes that differentiation of an infinity of observer mind states explains quantum phenomena. Quote, "A many-minds theory, like a many-worlds theory, supposes that, associated with a sentient being at any given time, there is a multiplicity of distinct conscious points of view. But a many-minds theory holds that it is these conscious points of view or minds, rather than worlds, that are to be conceived as literally dividing or differentiating over time." Michael Lockwood in Many Minds. Interpretations of Quantum Mechanics, 1995. The mysterious link between consciousness and reality inspired John Wheeler's idea of a participatory universe. As Martin Redfern described, many don't agree with John Wheeler, but if he's right then we, and presumably other conscious observers throughout the universe, are the creators, or at least the minds that make the universe manifest. The idea that consciousness precedes the material world has a rich history. It is found across philosophies and religious traditions. Where physical reality is seen as a dream or construct of a mind or soul. Quote, "For it is the same thing that can be thought and that can be." Parmenides in Fragment 3, circa 475 BC. A few millennia later, the philosopher George Berkeley echoed Parmenides, concluding that to be is to be perceived. Quote, "It is indeed widely believed that all perceptible objects, houses, mountains, rivers, and so on, really exist independently of being perceived by the understanding. But however widely and confidently this belief may be held, anyone who has the courage to challenge it will, if I'm not mistaken, see that it involves an obvious contradiction. For what are houses, mountains, rivers etc. but things we perceive by sense?" End quote. George Berkeley in The Principles of Human Knowledge, 1710. Hindus believe the universal mind, or world soul Atman, became the universe. Accordingly, the universe is not real, but the dream of a god under the spell of Maya, a temporary ignorance of the true reality. Buddhists believe that the mind underlies and forms everything. Quote, "All the phenomena of existence have mind as their precursor, mind as their supreme leader, and of mind are they made." End quote. Gautama Buddha in the Dhammapada, circa 500 BC. The Taoist philosopher Zhuangzhou said the world is a dream. Quote, "While he is dreaming he does not know it is a dream, and in his dream he may even try to interpret a dream. Only after he wakes does he know it was a dream. And someday there will be a great awakening when we know that this is all a great dream." End quote. Zhuangzhou in Zhuangzi, circa 300 BC. Reviewing answers. We've considered 7 proposals for self-existent things. Logic, truth, numbers, possibility, the universe, a higher plane, and consciousness. Yet so far, none of these is satisfactory as an ultimate explanation. None stands out as a final because that doesn't throw up a further why. Abstract entities, logic, truth, numbers. First, we have abstract entities, logic, truth, and numbers. But though these things are plausibly causeless, how could they cause anything? These things are eternal and unchanging, not to mention abstract. How can they cause anything like the huge dynamic universe we see? Quote, "So the cause of the universe must, at least causally prior to the universe's existence, transcend space and time and therefore cannot be physical or material. But there are only 2 kinds of things that could fall under such a description, either an abstract object, like a number, or else a mind, a soul, a self. But abstract objects don't stand in causal relations. This is part of what it means to be abstract. The number 7, for example, doesn't cause anything." End quote. William Lane Craig in Reasonable Faith, 1994. Possibility, mathematical consistency. What about all possibility? If all possible things exist, then our universe would be counted among those possible things. But why should possible things be actual? As J.J.C. Smart remarked, that anything should exist at all does, seem to me, a matter for the deepest awe. Existence is what we seek to explain. And there is another issue, why is our universe so simple and ordered compared to all else that exists in the space of all possibility? Quote, "Tegmark's proposal, however, faces a formidable problem. The number of mathematical structures increases with increasing complexity, suggesting that typical structures should be horrendously large and cumbersome. This seems to be in conflict with the simplicity and beauty of the theories describing our world." Alexander Valenkin in Many Worlds in One, 2006. The physical, the universe, physical law. If the universe alone exists, it explains exactly what we see. But there would be lingering questions. Why does consciousness exist? Are abstract entities real? And perhaps the biggest mystery of all, why should this universe, or its laws, be the only real ones? As Lee Smolin asked, why do these laws, and not others, hold in our universe? Does the existence of laws require some higher principle? Quote, "Although science may solve the problem of how the universe began, it cannot answer the question, why does the universe bother to exist? Maybe only God can answer that." Stephen Hawking in Interview, 1988. Higher planes, God, multiverse, simulation. We might appeal to a higher cause to explain the universe we see. But as J.J.C. Smart reminds us, if we postulate God in addition to the created universe, we increase the complexity of our hypothesis. We have all the complexity of the universe itself, and we have in addition the at least equal complexity of God. This seems true for any higher principle. For example, if we presume our universe is the result of a simulation in a higher reality, what's responsible for that higher reality? Quote, "Whatever our final theory of physics, we will be left facing an irreducible mystery. For perhaps there could have been nothing at all. Not even empty space, but just absolutely nothing. If you believe God is the creator, well, why is God that way?" The religious person is left with a mystery which is no less than the mystery with which science leaves us. End quote. Steven Weinberg in Closer to Truth, Cosmos, Consciousness, God, 2008 and 2009. The mental, mind, soul, consciousness. If consciousness is causeless, it could explain why perceptions exist. But if reality is only a dream or illusion, why do our perceptions appear to follow along with a universe adhering to physical laws? If it's all an illusion, what's the source of this illusion? Quote, "Even if everything in this universe were an illusion, there would still have to be something outside this universe that generates the illusion." End quote. John A. Leslie and Robert Lawrence Kuhn in The Mystery of Existence, 2013. A causeless cause. What we seek, and have so far have failed to identify, is a causeless cause. This is something that not only has a plausibly self-existent and causeless nature, but also plausibly accounts for the reality we see. We've found things that appear to be causeless, logic, truth, and numbers, but these things also appear incapable of being a cause. Conversely, we've found things that could be a cause, the universe, a higher plane, and consciousness, but they don't seem causeless. Then there is possibility, for which we have reason to question whether it is causeless and whether it causes what we see. We find an almost inverse relation: the more plausibly something is causeless, the less plausible it seems to be the cause for what we see. A causeless cause would provide us with a complete explanation. It would explain both itself, and the properties of observed reality. It would describe the relation between the mental and material. It would tell us why the universe exists and why it has simple, ordered laws. To progress, we need to find the connecting glue, the missing piece of the puzzle that shows either how a causeless thing accounts for the reality we see, or alternatively, why the reality we see is causeless. 3 modes of existence. In reviewing the 7 categories of possibly causeless things, we encountered 3 modes of existence. Loosely speaking, they are: mathematical existence, material existence, and mental existence. Mathematical existence includes abstract entities, logic, truth, numbers, math, properties, forms, equations, relations, possibility, structures, laws, and principles. This mode might include religious concepts of divine law, will or order, Tao or logos, the infinite indivisible truth, Asha or Govinda, and divine mathematics. Material existence includes matter, energy, the vacuum, spacetime, physical law, the universe, the multiverse, particles, forces, fields, and physical systems. This mode might include what religions refer to as creation, cosmos, the material plane, and Maya or illusion. Mental existence includes mind, consciousness, observations, perceptions, ideas, and dreams. This mode might include religious concepts of the mind of God, world soul, Atman, and souls or spirits. What is the relation between the 3 modes of existence, math, matter, and mind? Quote, "My viewpoint allows for 3 different kinds of reality: the physical, the mental and the Platonic mathematical, with something, as yet, profoundly mysterious in the relations between the three. Roger Penrose in The Big Questions, What is Reality? 2006. Math, matter, mind? Of the three modes of existence, does any stand out as being more fundamental than any of the others? What is their relation? If one of these modes of existence can be shown as primary, while the others are derivative, then we might close in on a causeless cause. A common view of physicists is that matter produces mind, and mind produces math. But even among physicists, this view isn't universal. Quote, "The triangle suggests the circularity of the widespread view that matter arises from the mind arises out of matter, and that matter can be explained in terms of math." Non-physicists should be wary of any claim that modern physics leads us to any particular resolution of this circularity, since even the sample of three theoretical physicists writing this paper hold three divergent views. End quote. Pete Hutt, Mark Alford, and Max Tegmark in On Math, Matter, and Mind, 2006. What is the reality of these modes of existence? Are all on equal footing? Or is one more fundamental while the others are derivative? Materialism, matter is primary. Materialism is the view that matter is fundamental. It assumes mental states are the byproduct of particular material arrangements, for example brains, and that mathematical objects, if they exist at all outside of minds, have no bearing on the material world. Materialism is a popular, if not conventional, view among physicists. Materialism can explain why our perceptions follow the patterns of physical law, but it has difficulty explaining why matter gives rise to mental states. This is the so-called hard problem of consciousness. Materialism also hits an explanatory dead end trying to answer why matter exists and why it follows simple physical laws. Quote, "If eager to know the world's structure, ask the scientists. Science, however, seems unable to answer some key questions concerning the structure. For start, why is the structure an orderly one? Why do events so often develop in fairly simple and familiar ways, leading us to talk of causal laws? Then there is what can seem the biggest question of all. Science investigates the world's structure, but why is there anything at all to be structured? Why is there a cosmos, not a blank? Why is there something rather than nothing? Science cannot answer this." John Leslie in A Cosmos Existing Through Ethical Necessity, 2009. Idealism, mind is primary. Idealism is the view that mind is fundamental. It assumes mental states are the basis of reality, and that the matter that seems to exist, exists only as thoughts and perceptions in minds. Idealism is expressed by Eastern religions, theologians, and mystics. But increasingly, physicists recognize they can't so easily do away with the observer. It seems the observer plays a necessary, if not fundamental, role in any description of reality. Quote, "Consciousness cannot be accounted for in physical terms. For consciousness is absolutely fundamental. It cannot be accounted for in terms of anything else." End quote. Erwin Schrödinger in Interview, 1931. But idealism doesn't answer everything. It doesn't explain why minds are bound up with the patterns of matter in a material world. Quote, "We find that our perceptions obey some laws, which can be most conveniently formulated if we assume that there is some underlying reality beyond our perceptions. This model of a material world obeying laws of physics is so successful that soon we forget about our starting point and say that matter is the only reality, and perceptions are nothing but a useful tool for the description of matter. This assumption is almost as natural, and maybe as false, as our previous assumption that space is only a mathematical tool for the description of matter. We are substituting reality of our feelings by the successfully working theory of an independently existing material world. And the theory is so successful that we almost never think about its possible limitations. End quote. Andre Linde in Inflation, Quantum Cosmology, and the Anthropic Principle, 2002. Platonism, math is primary. Platonism is the idea that math is fundamental. It assumes abstract objects are the most real, and that everything we see and perceive is somehow derivative from this higher existence. Platonism is popular among philosophers and mathematicians, whose job is to study the objective properties of abstract things. If mathematical objects form the basis of reality, it might explain why the material world is so mathematical in its form. Quote. In a famous 1959 lecture, physicist Eugene P. Wigner argued that the enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious. Conversely, mathematical structures have an eerily real feel to them. They satisfy a central criterion of objective existence: they are the same no matter who studies them. A theorem is true regardless of whether it is proved by a human, a computer, or an intelligent dolphin. Contemplative alien civilizations would find the same mathematical structures as we have. Accordingly, mathematicians commonly say that they discover mathematical structures rather than create them. Max Tegmark in Parallel Universes, 2003. Where Platonism falls short is in explaining how abstract objects lead to material or mental existence. According to Leibniz, the difficulty is explaining how from eternal or essential metaphysical truths there arise temporal, contingent or physical truths. What came first? For each of the three modes of existence, there is an ancient school of thought holding that mode of existence as most fundamental. The mathematical, Plato believed that abstract entities were the most real, and that the material world was derivative. The material, Plato's foremost student Aristotle, disagreed, saying material substances were more real than abstract forms. The mental, several centuries later, Plotinus argued that mind was more real than the material reality it perceives. Today's scientists, mathematicians, and philosophers seem no closer to an answer on whether math, matter, or mind came first. Does mind give rise to math, or does math give rise to mind? Does matter give rise to mind, or does mind give rise to matter? Does math give rise to matter, or does matter give rise to math? To unravel the mystery of existence requires that we understand the relationship between these modes of existence. Only then do we have any hope of identifying an ultimate explanation, a causeless cause. Quote. To address the nature of reality we need to understand its connection to consciousness, and mathematics. End quote. Roger Penrose in The Big Questions, What is Reality? 2006. Are they one? Various thinkers have suspected the three modes of existence to be connected and perhaps are all aspects of one ultimate reality. Mind and matter as one. Modern physical experiments have revealed something inseparable between the mind and the observed physical reality. Quote. As we penetrate into matter, nature does not show us any isolated basic building blocks, but rather appears as a complicated web of relations between the various parts of the whole. These relations always include the observer in an essential way. The human observer constitutes the final link in the chain of observational processes, and the properties of any atomic object can only be understood in terms of interaction with the observer. This means that the classical ideal of an objective description of nature is no longer valid. The Cartesian partition between the I and the world, between the observer and the observed, cannot be made when dealing with atomic matter. In atomic physics, we can never speak about nature without, at the same time, speaking about ourselves. Fritjof Capra in The Tao of Physics, 1975. Quote, "Aren't we mistaken in making this separation between the universe and life and mind? Shouldn't we seek ways to think of them as one?" John Archibald Wheeler quoted in Trespassing on Einstein's Lawn, 2014. Math and matter as one. Likewise, mathematicians and scientists cannot help but notice a mysterious link connecting mathematics and the physical world. Quote, "There exists, unless I am mistaken, an entire world consisting of the totality of mathematical truths, which is accessible to us only through our intelligence, just as there exists the world of physical realities. Each one is independent of us, both of them divinely created and appear different only because of the weakness of our mind. But, for a more powerful intelligence, they are one and the same thing, whose synthesis is partially revealed in that marvelous correspondence between abstract mathematics on the one hand and astronomy and all branches of physics on the other." End quote. Charles Hermite in Eloges académiques et translation page 323 1912. Quote, "Maybe the relationships are all that exist. Maybe the world is made of math. At first that sounded nuts, but when I thought about it I had to wonder, what exactly is the other option? That the world is made of things. What the hell is a thing?" It was one of those concepts that fold under the slightest interrogation. Look closely at any object and you find it's an amalgamation of particles. But look closely at the particles and you find that they are irreducible representations of the Poincaré symmetry group, whatever that meant. The point is, particles, at bottom, look a lot like math. End quote. Amanda Gefter in Trespassing on Einstein's Lawn, 2014. All as one. If matter and mind are two aspects of one reality, and if math and matter are likewise two aspects of one reality, then all three must be connected, all would be reflections of one underlying reality. Quote, "So how do the elements of the Trinity fit together, the phenomenological world, the physical world, and the mathematical world? On the unargued assumption that the principle underlying ultimate reality is radically simple, it will here be conjectured that these three realms are one and the same under different descriptions." David Pearce in Why Does Anything Exist? 1995. A Path to Reality. For millennia, philosophers have debated the relation between math, matter, and mind. For millennia, they've sought a causeless cause. Despite this, philosophy has not yielded any definitive answers. Perhaps science can shed new light on this question. Science allows us to test and decide among competing theories. Science provides opportunities to discover the missing piece of the puzzle and explain how and why a causeless thing gives rise to the reality we see. As it happens, discoveries in the field of mathematics in the 20th century found this missing puzzle piece. We now know a viable link between eternal or essential metaphysical truths and temporal, contingent or physical truths. We can explain how reality can emerge from self-existent, causeless truth concerning numbers and their relations. But without hard science and observational evidence to back it up, how can we ever know if this explanation is right? How can we ever escape from the morass of inconclusive philosophy? Fortunately, discoveries in the fields of physics and cosmology, also occurring in the 20th century, provide exactly this support. We not only have found a plausible path to reality, we have evidence for it. 20th century mathematics. Many consider the field of mathematics to be mostly uneventful, unchanged since Euclid defined the laws of geometry 2,300 years ago. But at the turn of the 20th century, The field of mathematics was in a state of crisis. The field was shaken to its foundation. Math was broken, and it had to be rebuilt from scratch. During this Reformation, monumental discoveries shocked and dismayed mathematicians. In the first half of the 20th century, logicians and mathematicians discovered a provably self-existent thing. In the second half of the 20th century, they showed how, under certain assumptions, this self-existent thing could account for the reality we see. Might this thing be our causeless cause? Let's see what mathematicians found, and how they came to find it.